Observability allows engineers to understand what is going on inside their systems. In its most raw form, observability comes from log data. Modern systems have many layers of logs: virtualized cloud infrastructure, container orchestration, the container runtime itself, and the application logic that is running within that container. With all of these layers, it's not practical for a developer to have to sift through layers of logs every time a bug occurs in production, or a deployment fails integration tests. Higher level observability tools include charts, distributed tracing tools, and monitoring services. With proper observability, developers can save time during incident response. Day-to-day software development becomes safer and more comfortable. Stripe is a payments company for developers. This episode is the first in a series of episodes profiling different aspects of the company. Our guest today, Cory Watson, leads the observability team at Stripe, and in subsequent episodes, we will explore infrastructure and machine learning at Stripe. Throughout these episodes, you will get a sense for how Stripe's engineering culture works. We hope to do more experimental series like these in the future. Please give us your feedback for what you think of this format by sending us email. You can join the Slack group. You can also fill out our listener survey that we recently created. All of these things are available on softwareengineeringdaily.com, and they're tremendously helpful for us if you give us some feedback. So thanks, and I hope you enjoy this episode and this series of episodes about Stripe. Heroku platform manages all downstack components, freeing users to focus on application operations, not infrastructure. Heroku Operational Experience provides integrated tools to increase application visibility, diagnose issues, receive proactive notifications, and remediate issues to help developers and operations staff maintain apps in a healthy state. Listen to our podcast with Heroku that was on February 28th to learn about Heroku's metrics platform architecture, the best practices for monitoring application user experience, and the importance of application health. Heroku is a loyal sponsor of Software Engineering Daily, and I also use it personally and love the platform. So check out that episode if you're interested in learning more about the underpinnings of Heroku. I hope you enjoy that episode, and I hope you are enjoying this episode. And let's get back to it. Cory Watson leads the observability team at Stripe. Cory, welcome to Software Engineering Daily.
Hi, thanks for having me.
When you joined Stripe, there was not much visibility into how the system was working at an engineering level. Describe the state of observability when you joined Stripe.
This is great because I have a good anecdote prepared for this. So my first day at Stripe, which basically like all startups these days, is that you're supposed to ship some code, right? Like you're not really active until you're actively contributing. So therefore, I remember in one of our spin-up meetings, as we call them, where they teach you how to be a Stripe. They're like, okay, today we're going to add ourselves to the About page at Stripe, which you go to our About page. It has a cool like animation and everything. And I'm like, hey, this sounds fun. So I start modifying some code, and then we resolve the Git conflicts that we had. And they're like, okay, so to get this on the site, you just type these commands to deploy the site. And I'm like, great. How do I know if it worked? Like, do I just go look at it? Is there like a dashboard that tells me whether or not I just broke Stripe? Because remember, this is my first day. I'm terrified, right? We process credit card transactions. So lo and behold, they're like, no, don't worry about it. It's fine. Like, you just ship the site. Like, it's not going to hurt anything. And I'm like, okay, I know I'm the new guy, but like, seriously, where do you go look to see if the site works after you deploy it? And they're like, no, it's fine, really. You don't. You just ship it and then it's there. And I'm like, cool. I know what I do at Stripe now. And that's kind of the story at least that's the story I tell of how
Meaning because when you started, there was no observability into what happens after you ship the site, you decided you needed to create that state of observability.
Well, yeah, and to be fair, there were a couple of dashboards and things, but what I was most taken by was just that it wasn't a cultural thing. It wasn't that if I'm going to do these actions, I'm going to go and verify or be confident that the changes that I made are there. Like, it's not enough to just go look at the website, because there's so many people that are using so many different parts of what Stripe is that we need to be confident that this hasn't had ramifications somewhere else, right? So I think the difference in where we were then versus where we are now is that we are much more thoroughly instrumented to the point that you can expect to be told proactively, hopefully, that something has gone awry.
That word proactive, that has come up in a number of previous shows I've done about monitoring. Particularly, there was an episode I did with James Turnbull, who wrote a book called The Art of Monitoring, and he differentiated starkly in that book between the reactive monitoring and the proactive monitoring. You described the early observability at Stripe when you joined as being reactive. Can you explain what that means?
Well, first off, shout out to James Turnbull for his great body of work that has inspired people like me to work on this for a living. But for us, the reactive stuff, I think, was largely this idea that, look, something failed. Widgets were having problems, and so we've created something that looks for that case to occur again, where widgets weren't working. But the unfortunate part of what we do, and this is probably true for all industries, but this is the only one I know a lot about, you can't enumerate all possible failure modes. It's just not possible. And so instead of monitoring these individual failure cases, like we're garbage collecting too much, or there are too many of this type of failure, instead we have to elevate our thinking to be, well, what are the actual signs of health? What is the work that our service is doing? And is that work being done successfully and within the bounds of what we expect our customers to want? And so instead of this idea that we were focusing on things that had happened before, we have to focus on these high-level health indicators and use those as guides. It also has the added benefit of sometimes decreasing the amount of stuff that you're inundated with, because you're, instead of getting 15 different error cases alerting you, you're only seeing that at a high level, your overall health is poor or your response level is poor, or response timing, I guess.
You've alluded to this already. You suggest that creating this culture around observability is more important than selecting what tools you use or the particular instrumentation. Explain why that is.
So I think that it's easy to be distracted by the technology that we work on every day. Like at the sort of bottom of an observability stack, you typically think about time series databases or event analytics, or whatever your poison is for sort of doing this work. But at the end of the day, none of this stuff matters if we're not empowering and improving the engineering confidence and experience. And so to me, it's way more important to talk about what value we're creating. Like what are the things that we're trying to make better for our engineers or our users? If at the end of the day, it's about, decreasing the number of times we've woken up our engineers or improving the response time for our customer, that's the thing we need to be focused on, and not the specific technology that we're using. And so if culturally we are measuring these key indicators and focusing on them, we're less bothered by which specific technology, is this the right time series database? Like, to me, it's less about the tools and more about what those tools enable. Now, the tools are important too. I mean, they're fun. It's fun to talk about the technical side of it, and I get just as bad as everyone else. But to me, at the end of the day, this is about the value we're bringing to the organization.
And when you were trying to create this environment of observability, you went around to different areas of the company and you asked people what they needed in terms of observability. What were the answers that you got around the organization?
They were interestingly varied, but also, I think, had a largely common thread. I think that when we ask people these questions, they're most often going to present them in the context that they're used to. If you work on our, say, financial ops team, then you're going to talk specifically about some more money-oriented problems. But underneath them, there are some patterns. There are I'm not going to say very few, but there are a reasonably sized number of patterns in monitoring that we can sort of apply to these things. And so then it's about figuring out how to observe them and then how to help them get monitored. So I think the majority of things were that they wanted to know what was, if anything, was out of sorts, but they also didn't want to be inundated all the time. They wanted to increase the signal and decrease the noise. And that signal to noise ratio was probably, at the root of it, the most common thing we were asked for, because the lack of signal is also bad. So increasing that signal and decreasing that noise is probably the most concise summary of what we were told when we asked questions.
And as the culture of observability was being developed, how did you get the word out to everyone about the way that observability standards or best practices were evolving? Because Stripe is so decentralized, you would think that'd be maybe somewhat difficult, but it's because it's something you want unification on. Like in general, you obviously want a decentralized engineering force, but there are certain things that you want to unify on. I'm assuming that certain observability practices are one of those things.
Yeah, it's a very astute observation, because I think that, no pun intended with observation and observability, but I think that if you sort of like let everyone to their own devices here, you're going to end up with a lot of things that are difficult to compare. And measuring and comparing is kind of what we're all about here. So there were a handful of tactics. I think that one of the ways that this was easier to approach is to look at it sort of humbly and realize that this is one of those problems that we didn't have a lot of like internal vying for taking it. Like revamping the observability stack seems, I think it's super interesting, but apparently I'm in a minority because not everyone wants to go and change something like that. I also have done this in the past. I worked on the observability team at Twitter, and so I think that some of my past experience paved that road. I didn't like come in and do magic. I think that my reputation helped a little. But I think the biggest things that we were able to do to get this spread were two. We had to not be afraid to advertise as a team. Like we had to be willing to send emails and speak in front of engineering and invite ourselves to things and sort of make a little bit of a racket. Like we're trying to improve and make things better. I think it's no different than advertising if you're a standalone company, just internally. And then secondly, we relied, I think, very heavily on champions on other teams. So it was a really common thread to find someone on another team who, not on the observability team, but in some other part of the engineering organization, who really believed in this and say, what can we do to help you? Like, how can I empower you so that you become a cheerleader or advocate or evangelist for what it is that we're trying to do? And that also has a really great side effect of also improving what you're making, right? Because you're getting that feedback from this other person who's not only making themselves more hopefully empowered, but also making it so that when you have the next conversation, you've hopefully already got some of this stuff figured out and you've got an even better product than you had before. So it was sort of the culmination, I think, of all of these things were how we really spread it out internally. Because to your point, teams were fully capable of going and setting up their own stuff if they wanted to.
Indeed Prime flips the typical model of job search and makes it easy to apply to multiple jobs and get multiple offers. Indeed Prime simplifies your job search and helps you land that ideal software engineering position from companies like Facebook or Uber or Dropbox. Candidates get immediate exposure to top companies with just one simple application to Indeed Prime. And the companies on Prime's exclusive platform message the candidates with salary and equity up front. Indeed Prime is 100% free for candidates. There are no strings attached. Sign up now and help support Software Engineering Daily by going to Indeed.com/SEDaily. That's Indeed.com/SEDaily if you're looking for a job and want a simpler job search experience. You can also put money in your pocket by referring your friends and colleagues. Refer a software engineer to the platform and get $200 when they get contacted by a company, and $2,000 when they accept a job through Prime. You can learn more about this at Indeed.com/prime/referral. That's Indeed.com/prime/referral for the Indeed referral program. Thanks to Indeed for being a continued sponsor of Software Engineering Daily. If I ever leave the podcasting world and need to find a job once again, Indeed Prime will be my first stop. This term observability was not something that was widely used in the developer lexicon until I feel like maybe in the last year or two. Maybe I'm mistaken, but you can tell me whether I'm mistaken and why that term observability has started to get used so much.
Sure, I don't think you're wrong. I think I hadn't heard it much either. When I started at Twitter, the team was called Observability, and I know what that word means, so I assumed that was looking at stuff. I thought it was a pretty cool name, but over time I learned and perhaps sort of even backed into the idea that there's actually a much bigger thing here. So observability maybe wasn't common in computer engineering terms, but it is an important concept in other types of engineering. So it comes from control theory, which you're probably much more likely to hear about in mechanical or electrical engineering. And it's the idea that how well can we infer from external outputs what the internal state of a system is. And so in the past, I think you'd more likely hear about monitoring or something, but I think monitoring is just kind of one piece of the puzzle. We're like watching charts and we're building monitors that tell us that something has gone awry, but we're also doing things like reaching out and proactively taking care of things, instrumenting things, building tools that are not so simple, that don't just stop at time series. Sometimes there's event-based systems or much more complex systems. And this entire concept that you have to, from sort of beginning to the end of the engineering effort, invest in instrumentation and how your system works, I think sort of culminates in observability. I think we needed a bigger word because monitoring was just too small.
Yeah, and to put a finer point on that, I think it has something to do with the fact that these days our systems have so many layers of cloud infrastructure and virtualization, and there's container orchestration, there's the container itself. What are the challenges that are created around observability when you have so many layers?
That you obviously know a thing or two about it, because that's sort of the kind of stuff that keeps me up at night. I think the thing that is most difficult for me in this area is just how do we continue to provide the user with an actual pinpoint into where something has gone wrong. Right, like you've got a host, but the host could have many containers, and you may be running multiple services in all these places, and it's just like this sort of Gordian knot of problems. And how do we cut through that and provide them directly with an answer? I think in some respects, the container question makes some parts of this slightly easier, whereas it also makes other parts harder. I think it makes my job harder, which I appreciate, because I think that what we do is already difficult enough, asking people to instrument their code and all this other stuff. Add on top of that they've got to find ways to decorate their services with ownership information and all this other stuff is a tall order. But I think that when we have a container, containers are generally much more single purpose. Separation of concerns is much more of an idea that's stronger here, right? Like you don't typically run a container with all of your stack in it. You'll run one container for each of the things. And so that helps us with origin information. Like it came from this thing. And because these things are easier to throw away, they're often a little easier to adjust to our new standards. So I think it kind of cuts both ways though. The parts that are harder are, for me, how do I collect information? How do I aggregate metrics? How do I provide sort of a substrate of, a collection infrastructure here that we can use to get all this information to the sort of backing store in a quick and useful way for people? I think it makes my job harder, but I think that's the right direction for us to be going, because I want this to be as easy as possible for the engineer and, a little tougher for us.
Can you talk more about what the layers of infrastructure are at Stripe and what you've standardized on?
I think the root of this is probably talking a little bit about containers, which this is not my area. There's another team at Stripe that's much better to ask these questions, but we are on AWS, which has been a bit of a boon for us, I think, because we've been able to be more thoughtful about containers. But we're also a very security conscious company for very obvious reasons, which means we have a lot of, when you're talking about AWS and VPC, so virtual private stuff, and then you've also got all these security groups and stuff that we use to isolate things from each other. We have a set of tools that make that easier for us, so that the various networking components are there to keep things isolated. We do not the moment, I don't think we're running any containers in production. So that I think that kind of answers part of that question, because we're not actively doing it. But I think the reason we've been able to is because our tooling was very heavily based on spinning up instances in AWS as part of your workflow. So part of what I do as a service owner is I say, okay, I need a box of this shape, and then please spin those up for me. We do use ASGs, so auto-scaling groups with AWS we use heavily, which give us many of the benefits of quickly spinning up a like number of machines, but we have yet to invest as heavily in container stuff, and I think we're just being more thoughtful about it because I can choose relatively small instances to control my cost and the footprint of my service, while not necessarily having to commit to what is still a growing and nascent. I don't know if I'd say nascent, but there's still a lot going on in the container space.
Do you hear any discussion around like moving to on-prem because maybe as a somewhat commodity service? I mean, it's not a complete commodity service because it's obviously the user experience is differentiated, but it's in things that in services that resemble commodities, a lot of times you see the leadership having some discussion around moving to on-prem because the margins in a commodity business are much more important. But I don't know, maybe that's beyond your purview. Do you have any thoughts on that?
Well, I think you're right. I mean, in my previous company, we did choose to lease physical hardware. It was still hosted in another data center, but it was a similar sort of thing. It was commodity analytics, and so the margins were such that we did think about it that way. I think in our case, the agility that we get is also much higher. Like the return on investment is there for us, and plus I think something that's unique about Stripe that I often point out is that when I worked at past companies, we processed billions and billions and billions of events, and they were huge, but each individual event was like sort of lost in the shuffle. It was so small that it didn't represent significant value or anything like that. But every transaction we process here at Stripe is I'm not sure the word I want to use there, sacred or important or huge. Like, no one thinks that their service is processing useless events, but traditionally speaking, here we're talking about some movement of money that we're being asked to do. So also we tend to be at the tail end of someone's funnel. So we do a smaller number of transactions than say, a Twitter or a Facebook, because they're got all this, all my inane tweets, of course, are going through Twitter, and they don't represent a lot of money individually, only in the aggregate. But for us, every individual one of these transactions is very important. And so we tend to work at a smaller scale, I think. So I think that benefits us a little bit because we're just not as big in terms of like raw instance footprint or something like that, because we're just a little smaller in terms of transaction volume. But they're very important transactions, so there's sort of a give and take there.
Where are the blind spots in your current observability purview?
This is, I feel like you're some sort of dream wizard that like peeked into the things that keep me up at night here, because you've asked some really good ones, and this is probably the second. I think our blind spots are largely, well, there's a few of them. The first is things that don't happen very often. I don't mean cataclysmic things like meteor strikes or locust plagues. I mean like there's this one weird little thing that happens aperiodically. We can't really pin it down. There's a game internally that I've seen played a couple of times called Guess the Cron Job, which is to find something that's got a very seasonal period to it, like it happens every day at this time. But it's the things that are rare, and that and some of them are not even like bad. Some of them are things like, how do we internally help our security team like monitor VPN connections? That's a fairly human scale problem. Like there are only so many Stripes and they only connect from so many places. But how do we give them good visibility and good understanding of what the current scope of connections to the VPN are and stuff like that? That's one that's been particularly tricky. I think another one is like, how do we bridge the gap between our tools? Because observability encompasses instrumentation of like runtime performance and errors and kind of all these disparate systems, we expect people to look in, say, Splunk to find certain types of problems, or in Datadog to find another type of problem, or Sentry to find another problem. And so how do we, as a team, provide them with fewer blind spots sort of between these environments? Because do I have a good way to see this holistically? Because we rely on a couple of different vendors to do each of these things, and that's tricky. And then lastly, I think the systems are just complex, man. Like, we're not making software any easier. And so you asked earlier about layers. Like, we're talking about a lot of interconnected services as we grow and offer more features and more products. And just how do we understand sort of the network that we've created and provide individual teams with understanding of upstream and downstream and some things that maybe they don't even depend on that are affecting their services somehow, sort of giving people that knowledge of what's going on around them as we continue to silo information because we're specializing and getting bigger. How do we give people that visibility? And I think, I don't know, it's making me sort of shaky just talking about it, man. These are the things that as an observability team, I feel like we have a lot of opportunity to make Stripe so much better by fixing these problems, but none of them are simple.
I imagine there are also observability challenges where Stripe has to interface with banks because it's such an opaque request. And does an external API call to a bank give you the feedback information that you need to have observability around that transaction?
It's different per. Individual integrations aren't my cup of tea. I don't work on that team, but I do help them a lot. And interestingly, you continue your sort of like poking and prodding at all the things that are raw for me. This is another one. I think that we integrate with a lot of stuff, and so it's difficult because the level of not sophistication, I don't think, but just the types of feedback that we get. I think you made. To your question, I think that's exactly the root of it. Like, do we get good information back? And in some cases, we've got really great APIs that we're working with. And in some cases, we're working with batch jobs that don't communicate back to us for some period of time. And one of the things that can be very difficult is realizing whether or not that batch job did its thing. Like, the absence of information is sometimes the thing that we're the most interested in figuring out. And so, yes, it's a very difficult thing to do for some. Obviously, the ones that we use the most, they probably get the most exercise and therefore provide us the most feedback. But on the flip side, the rare ones are sometimes the ones that can be more difficult. So I think we kind of represent the gamut, right? Like, there's some that are good and some that we have less good integrations with, and it's a difficult problem that we still talk about pretty regularly. I have an upcoming meeting actually just to sort of hash on this with a particular implementation that we just can't figure out how to monitor well. But this goes back to your question about blind points. I think that there are some very tricky, especially batch-oriented problems that we have trouble figuring out.
What about irreproducible errors? I mean, this is kind of another form of observability blind spot where, okay, an error occurs and you don't log enough information on the first occurrence, and then you don't know how to reproduce it.
Yeah. Yeah. How do you fix these? Do you have an answer for me? I'd love to hear it. I think it's a couple of different approaches. For us, it's about layers. Like, how many different areas can we sort of capture information? And of course, there's a trade-off in that the more detailed information you have, the bigger and the harder that is to capture. So back to some of your questions about infrastructure here, to spend a brief moment on our observability stack. We're very heavily StatsD based. We actually have an open source project called Veneur, VENEUR, that is an open source implementation of Dog StatsD, which is a superset of StatsD made by Datadog. And so we have this first layer of metrics that are sort of things that we expected to measure, and they happen very frequently, and it's like runtime performance stuff. And that's where we're going to get most of our signal about the health of a service. Like, it is processing requests. They are happening in this amount of time. The error rate is this or that. But then the next layer of stuff that we've got is also, of course, exception tracking. Like, hopefully, if you have a sufficiently big error, you've got some sort of error catching here. But that's not always the case either. So we have a third layer of logging. So we're fairly... actually, Stripe is probably the most layered in terms of multiple observability systems that I've seen. We didn't rely very heavily on logging in my time at Twitter. There was no central index logging. And so Stripe has both index logging from every machine, which includes like very specific canonical lines that say, I just did some work. And we also have that high level kind of best effort metric parsing where we're sending stuff like over UDP just as fast as it happens. And so one other thing I'll say about irreproducible errors is many times I have found in our stack that they come from our various service like intersections. So you may have a service that dispatches to, say, service A talks to service B. If service B fails in some sort of cataclysmically bad way that it can't log or it can't send an exception or whatever you expected to see, then often we're able to find that from its dependency. So, for example, most of our API requests pass through a first layer, and that layer has one set of metrics that we then compare against the metrics from our second layer of API work, and we kind of watch the two of these. Like we actually alert on the health from the dependent service, and the service that we depend on has its own set of metrics that we also compare. And we sort of like A and B these, like this one looks okay and this one looks okay, so we're good. But if either of them differ, we have a problem. We actually have one chart on a main dashboard that says here's how many errors we see in service A and here's how many we see in service B. And if you subtract these and they ever don't equal each other, or if it's ever not zero, you've got a problem. And so I think that doesn't show you what the error was, which I think was your point, but it does at least get you in the neighborhood of knowing where to look, which I think helps. But I'd be super interested in hearing other people's thoughts on how to do these, because it's not an easy problem.
How does observability affect the deployment process?
This is actually something we're speaking about lately here, but I think the first thing that it does, if it's working well, is it gives confidence. Deploys can always be a little scary. They're certainly not something that you want to go wrong. I mean, everybody's had that sinking feeling when they realize that, oops, that deploy I just did broke. So the first thing that I think we can provide every day is visibility into what is happening such that you are confident. The second is not just the health of the service, but something that we teach in our spin-up classes about observability is that you should be thinking about how to measure the thing you deployed ahead of time. So if you and I are working on something and I've got a patch that says I'm going to decrease the amount of time it takes to perform this operation, well, hopefully when you review my code, you check and say, well, Cory, did you put a metric in there that times this so that we can check it after it's done? So the second is that you get this like actual validation that the work you wanted to do is actually being done. So that's the second one. The third is we're discussing internally now, like how much should signals from the current health of, say, the canary process, if you're doing canary deploys, or the blue or the green side, if you're doing blue-green deploys, how should those impact the tooling? Like, should we stop people from doing a deploy if we notice something? Also, I think an anecdote as to why this is so important, if we, for some reason, have dashboard issues that you can't see data, like let's say that we're delayed for some reason, or if the dashboards are broken for reasons that have nothing to do with Stripe as a service, we actually stop people from deploying. We lock everybody out, because if you can't see the effect of what you've deployed, I think that's a really scary place to be.
We talked a little bit about this earlier, but can you talk more about the standards that you have for the monitoring capabilities that every service has to comply with, and how you do people just import like a standard package and then they have distributed tracing and the monitoring things you need? How do you standardize that across the organization?
We have a few different ones. I think to understand some of it, it's helpful to know that Stripe kind of largely works off of the idea of a monorepo. So we have one large code base that covers how most of the core API that you as a user would interact with at Stripe. If you are in that world, which most people are, you get almost all the tools for free. So you get a metrics library that's got convenience methods for measuring the duration of things, or for emitting errors, because errors need to be emitted at maybe different sample rates than your normal counter. We have exception handling, and all that stuff comes for free. Distributed tracing is not something we're actively doing right now, but it's something that we're working on, and that will also come kind of for free, as you just described. We, as an observability team, also maintain, this is outside of that monorepo, we also maintain a lot of different tools for other systems. So we've got infrastructure teams that are maybe not in the monorepo and are perhaps working directly sort of at the low-level Linux layer, and so they need a convenient way to emit metrics directly on the machine. We have other language repos. So Stripe's fairly polyglot. We got a lot of Go, a lot of Java, JVM stuff. Java and Scala are both here. Ruby, a lot of Python in some places. So all of these we maintain client libraries for as an observability team. Some of them are we'll just do patches to open source projects, and some are completely separate projects because we felt the need to create some new stuff there. So outside of that, something else I want to talk about is maybe the metric naming, and then also the conventions around monitoring. So I've got a lot to say about this, I guess. Metric names, we probably, you just mentioned at the beginning of this where sort of observability began in my time here at Stripe. We went from not having an observability team to now being a team of 6 people. And so some of this, we didn't do a great job of naming conventions at first. We sort of let everybody kind of do what they wanted. I want to give a shout out to the Prometheus developers for creating a really good guide on how to name metrics. We borrowed a lot from that. And so there are certain things that we do, like ask people to put the certain conventions in the names. Like if you're going to emit a timer that's in milliseconds, we ask people to make that a part of the metric name. We use a tag-based system, not a dot naming scheme like, say, a graphite. So we have a few dots, like maybe foo.bar.baz_duration_ms. These types of signals are very helpful for engineers because they don't have to guess at what the metric is measuring. It's a little more obvious. Getting everyone to sort of follow that convention is not something that we enforce through any like programmatic or linted methods, but it's something we want to add. We recently, as a team, probably in the last 3 months or so, have come up with what we think is a fairly strong convention for how metrics should be named, and we are going to work on linting and getting that stuff into our standard library so that everyone benefits. We found very little pushback from this. People seem to largely be accepting of whatever conventions we think up, and probably partially because we asked. We didn't just tell people they had to do it our way. As for monitoring sort of conventions, that one's probably the one that we're the least pushy on, and I think we need to improve a lot. One of the best things you can do as observability or monitoring or whatever ops group at your company is just get people to write better monitors. Some of that we can improve with tooling. I know we're very big fans of not using scripted tools that automatically generate monitors, because that tends to let you make a bunch. We're more a fan of hand curating them and building them in the UI so that you can compare them to historical metrics and say, well, look, this would have fired here, so we've got a good, confidence that it will fire in the future. And also things don't send them in email to yourself. Don't be that person who sets up an alert that, calls you in the middle of the night. Use your team. Be sure to link to runbooks if you use them. If you have specific dashboards that can be helpful, link to those. We have a concept here we call investigation dashboards. We have a certain set of monitors that my team maintains for everyone. So we'll tell everyone at Stripe, if you've got a box that runs out of disk, we will send you a ticket in Jira that's got that. But we also send you a special dashboard that was made just for diagnosing disk full issues. And so we've tried to push this idea that if you're going to bother somebody in the middle of the night, even if it's yourself, you owe 3 a.m. self is not nearly as fast as 3 p.m. self. So the more you can do to sort of help future self, the better you'll be in your responsiveness. So we're trying very hard to set standards on those and sort of define them for ourselves. As an organization, I don't think it's something that we're doing a great job of and that we need to invest a lot more in. In fact, I think I made a ticket just a few days ago that said we need to sit down and do some linting, because the team sort of agreed that this was something we could do that would really sort of raise the water level for everybody.
Speaking of ticketing, when a problem occurs at Stripe, a ticket is auto-generated. What are the qualities that every ticket should contain?
So for us, there are a few. We actually have a guide for this that says if you're going to automatically generate a ticket for someone, what information should it have? So this is sort of a softball. But I think it's important because this is information we've won from a lot of experience. The first thing is you should make a ticket that's actionable. You should be able to say for any, whether it's a page or a ticket or any stimuli that you apply to someone, is this actionable? Does it tell me what I can do? I like to pick on Java garbage collection a lot, I guess, because I spend a lot of time as a JVM nerd. But like, it isn't really actionable to say, hey, guess what, Cory? You're doing a lot of garbage collection. I don't know what to do with that. So the first thing is like, this unit of work that I'm giving you needs to have some sort of action. There needs to be instruction as to what I can do. That's generally for us going to be a pointer to a runbook. So we've taken this monitor that we wrote, and when it bothers somebody, it's got instructions on what you can do. You know, here's what you can look at, here's some commands that you can run, here's the expected and maybe common problem. Like if we see that Veneur, our metrics pipeline daemon, is like having trouble sending metrics, there are some things that we can expect that you should do. If it is sufficiently large, you got to like lock deploys, and you can't let people do deploys. So these are all actions that people can take. Secondly, they need some context. So can we give them a dashboard that has the context to help them understand what's going on? Was there a deploy recently? Like, that's really good context to have. Are there any other changes to key metrics that are going on here? Like, if my success rate is low, is my request rate depressed or increased? Like, am I getting more requests or less requests than normal? Are any of my dependent services failing? Stuff like that. The more information we can give in that context, the better the person can respond. Lastly, our favorite thing to add is some mechanism for feedback. Is there a way that this person can ping us to say, hey, this was not helpful. Like, this was a completely inactionable and unhelpful message. Or, this was really great, and it pointed me directly to a problem. So to run back over them, like just giving them some action that actually needs to be taken, which is, by the way, a great litmus test for should this thing even exist. If I can't decide what to do with it, maybe it shouldn't page me. Secondly, some context, so that when you're, a little bleary-eyed at 3 o'clock in the morning and you can't remember where your other shoe is, much less whether or not this big complicated set of services is working, can I give them as much context as possible? And lastly, do they have a way to give us feedback or their own team feedback? Like, we don't manage every monitor that runs within Stripe and keeps an eye on things. So something we advocate for is put something in there so that you can, as a team, say this was not useful or this was, and then use that in follow-ups when, hopefully the problem has gone away.
How do you use Slack to improve observability?
It's a fine line. It is very easy to be too chatty, I think. We have a couple of different techniques. Typically, if someone is paged, then the notice that the page occurred is emitted into that team's channel. So, for example, if today, a common problem for us is when something goes wrong in another place in the company, we'll get a lot of exceptions sent into Sentry, which is an exception monitoring tool. And so we will see a page that says the backlog for events into Sentry has gotten high. So that is kind of good in multiple ways. One, it's like a little less interrupting during the day to see a Slack message than it is to get paged. I know I love to intercept it before it rings my phone. I don't know who calls people anymore like barbarians, but when the machines call me, it makes me extra angry. And so that helps. But it also provides a lot of context for the people around you. So your teammates that may be asked to help in the event of a problem, they get aware that this is happening. And thirdly, people that are not on your team who would love to know if your services are in a good place, they can just peek right in. They can see that this is going on. Another way that we use it is when you have like a warning and a critical level for an error. We will often have the error emit to Slack at the warning level, because it's not necessarily to the point that we need to page anybody, but we want to provide some context if you happen to be looking. And then lastly, if it does go into critical, we additionally will, of course, emit it to Slack with the fact that you got paged, because usually the indication to Slack contains a chart or something that provides you with some context. Like, here's the line showing the last hour of this important metric, so that we can ensure that like it just happened or it's been happening for a while or something like that. We're not heavy chat ops users at Stripe, but most of these tools, when they go to Slack, have some ability for us to influence them. I can resolve or acknowledge a page using the Slack integration with PagerDuty. With Datadog, I can click directly through to look at the monitor. And then outside of monitoring, we also share a lot of charts in Slack. So it's very common during an incident to use Datadog's snapshot tool to say, here's a problem here that I saw on this one chart, and then someone else will riff off that and say, oh yeah, I was looking in this other chart and I see the same error you're seeing. And so between all of these, we're providing all this context and a historical backlog that we can use in a postmortem or after, the incident's over if we don't have a formal postmortem to sort of assemble what happened and the order that it happened. We also have some tools around like feature flags. When we enable and disable feature flags, those go into Slack so that we can see them for context. And we have some like special chat commands that if you say the word paper trail, it automatically gets picked up and logged so that you can then look back at it later. So it's fairly common here that if I'm going to make a change like puppet a bunch of machines at once so that a change goes out, to say paper trail, going to do this thing that might break some stuff, and that provides context for everyone around you. So I think it's mostly about providing context. So I basically gave you just like 7 different ways that we give context is probably the root cause of all of those.
We've mostly been talking about observability at a technical level. My sense is that observability is also growing in importance at the executive level, and that there's a relationship between the lower level engineering metrics are in terms of quality and how good the higher level executive metrics are. Does this resonate with your experience?
It does. In fact, I'd say probably on 2 levels. I think that on one level, being able to provide to your leadership a good understanding of the key indicators for health or uptime or responsiveness or what have you is critical. Especially, if I'm talking to the head of engineering, I don't want him to have to like dig through these 30 different dashboards to figure something out. Or if I'm talking to the CTO and she needs to see, a very high level understanding of our health, I don't want any of these people to have to, they protect me from a lot of stuff. So I'm going to protect them from our complicated dashboards unless they want to dig in. But then I think that's the conventional wisdom, right? Like we always think about providing, better and simpler dashboards so that folks that want higher level overviews can get them. But I think there's also a strong aspect where observability is important for your user, because we have a lot, this is something we've been discussing a lot lately within our observability team, because as we've talked about this journey of getting it to be a culture thing at Stripe, we've kind of done okay with engineering. I'm certainly not going to say we're done. I think it's sort of asymptotic and constantly approaches done, but never will be. But one place where I think we could do much, much better is taking the tools that we've created for engineers to see into how their services work and then extend that on to helping our users. So, they don't need to go and look at, like, say, the same type of dashboard I would look at, but they certainly should be able to answer questions. Like, how often have you reached out to some company and been like, I'm sort of seeing things are a little slow. Is it just me? Or, how many times have you tweeted and been like, is GitHub broken? Like, pull requests are not showing up as quick as I expect them to, right? Like, these are all things that we can help people answer these questions. And then we can also empower our support staff, our user operations staff, our account managers with a lot more information about how things are performing from the perspective of our customer. And if you want to go even further, external monitoring so that we see what the real user experience is. These are all still part of observability, because this is about figuring out what the internal state, like, is this service working? Is it doing the thing that I expect, but from its external outputs? And so to me, providing user visibility into something that we have typically seen as an engineering problem is very much about what we're talking here. Like, I think that's the next level of what we do, and where observability becomes even bigger than just talking about, am I garbage collecting too much, or do I have too many file handles open? So to me, it's a double answer. Like, I need to help the CTO and CIO or whomever, but I also need to help average end user, because at the end of the day, that's what we're here for. So I mentioned earlier that providing value to Stripe's engineers was what it was all about. It wasn't about the tools. But in addition to that, I think providing value to our user is sort of the next level for us. How can we make the customer experience even better through the engineering work that we're doing for observability?
I don't think that you're an expert in machine learning, but do you see any opportunities for machine learning to improve observability?
So I've had a long experience with this sort of over time. Like, I remember at Twitter, we often would have folks from our machine learning staff bring over ways and ideas of like predicting when things were going to go awry. It's tricky for 2 reasons. This is something that's near to me because we're actively working on some internal tools that help us with machine learning to sort of investigate this. I think on the one hand, there is a huge upside for not having to define static thresholds. You miss so much by saying if the error rate goes above this, or if the latency goes above this, or if the number of requests go below that, because you constantly get on this treadmill of adjusting and having to make multiple alerts for different slight deviations of the rule, which I think is kind of just a bad place to be. Machine learning provides us with the ability to sort of detect an anomaly or an outlier, which are both really, really powerful, but they're also a little tricky. So many different times here we've seen like a monitor that fires and no one can really figure out why. Like, why did this trigger? Like, what was going on here? And machine learning makes that considerably harder because the results are often sort of opaque. So I think there's a huge potential upside to this, but also it requires vendors or us as engineers when we're implementing this internally to be really transparent about how we got here. So capturing the state of the machine, if you will, like, and showing in friendly ways why we saw this, I think is really important. But there's huge upside because it takes so much of the mundane work out and gives you so many opportunities to not miss things. We are more and more often recommending people use anomaly detection monitors in place of sort of static ones, partially because they're easier, but partially because the problems that we at Stripe, as we get more mature in this monitoring of our internal systems, we're also sort of like running out of easy problems, which I kind of liked the easy ones because they made me look good. The harder ones are trickier, but hopefully we continue to do a good job with them. So I definitely am excited about it. I think we're going kind of slow and thoughtful about it because I am scared of creating instances where something fires and we don't know why, and I don't have good answers for the people on the other
end. Good customer relationships define the success of your business. Zendesk helps you build better mobile apps and retain users. With Zendesk mobile SDKs, you can bring native in-app support to your app quickly and easily. If a user discovers a bug in your app, that user can view help content and start a conversation with your support team without leaving your app. The conversations go into Zendesk and can automatically include information about the user's app information, device information, usage history, and more. Best of all, this is included with Zendesk for no extra charge. Use the out-of-the-box iOS UI to get up and running quickly, or build your own UI and work with the SDK API providers. Keep your customers happy with Zendesk. Software Engineering Daily listeners can use promo code SEDaily for $177 off. Thanks to Zendesk for supporting Software Engineering Daily, and you can check out zendesk.com/SEDaily to support Software Engineering Daily and get $177 off your Zendesk. What did you learn about observability in your past lives at Twitter and Keen? Keen is an analytics company, for those who don't know, metrics and analytics company.
Sometimes I feel like I work on code so that I can visualize it. I think for me specifically, I'm very passionate about this because we make very complicated stuff, and the way that I deal with that is by making visual representations. I guess I'm just a visual learner. When I joined Twitter, I think I was initially enamored by the fact that the company, I didn't join Twitter's observability team from jump. I joined as an SRE working on message queues. And I was so quickly just infatuated with the idea of what they were doing because it appealed to that visual nature of mine. But what I learned from that was, I came into that team as a user instead of as an implementer. And I think that was a real big upside. I think the biggest thing I have learned is always, this goes back to your tools question, always remembering that it's not about the tools. It's about the value that we're providing to our user, be that an engineer or the user that benefits from the uptime that we've enabled, or the reliability that we've enabled. And so partially it's like learning that people aren't bad, right? Like, they don't mean to set up a service that breaks, or they don't mean to not instrument a thing. The more easily these people can do this, the more powerful they'll become. Like, making monitoring and observability tools as easy as possible is something that I've learned. Learning that like no one wants to be woken up in the middle of the night is a big one. So proactively engaging that. Also just proactively engaging dissent. I think that being sort of, I'm not sure the word I want to use here, but like being flippant, I guess, about monitoring problems and all these other things that manifest themselves. Like I want to nip that in the bud. I don't ever want people to talk like, well, we get paged all the time, so and so. Like I really am aggressive about reaching out to people and asking those questions. Like how can I cut this off? Because I think that one of the biggest contributors to burnout in our industry is just not being proactive enough about people who are getting paged too much or whose services are failing. These are all things that we have a direct capability to improve. I know that when I was at Keen in these early startup phases, like I let myself get burned out on those, and I could have done even more for myself and for everyone around me by investing in these tools more. And then here at Stripe, I think what I've learned is people want this, and the more we can invest in it and the more we can help them, the better. One of the questions I'm commonly asked when I've spoken at conferences and stuff is like, how did you make it possible for there to be an observability team at Stripe? How did you get approval? And I didn't. I just sort of like sat here and busted my ass to make it happen, and just worked on it constantly. In between every other project I was doing, I was always selling this idea that if we invest in this, we can get so much more out of it. And so I think to roll it all back here, like Twitter really weaponized my love of observability as something that could empower and make people better. At Keen, I think I saw it firsthand in myself because I wasn't focused on observability there. I was focused on general engineering. And I got to use my tools a little more, which is always, dog fooding is very enlightening. And then lastly, here at Stripe, I like sort of stepped out and took this risk to say, we're going to make this part of the culture and we're going to build a team around it. And I basically I don't want to say whined about it because you're not whining if you're also doing the work. I was investing in the work and basically incessantly saying that we needed to have this and look at the value that we're getting from this investment. And over time, we've shown it by focusing on the value that we're providing. And so I think, I don't know, those are the high-level things I picked up, I think.
If there's an engineer listening to this and they're seeing that you create an entire team around a role that, like, I don't think I've interviewed anybody that's an observability engineer, but you create an entire team that is observability. If there's somebody listening to this and they want to create just a culture of observability, not as ambitious as a specific role or a specific team, but maybe they work at a place where they think observability would be useful. If they work at a place that is not as open to change as Stripe and is not as open to somebody that comes in and says, even if they are busting their ass and doing the work, they're not open to the idea of observability teams. What are the steps you would recommend that engineer take to at least just get a culture of observability in the direction that you have implemented at Stripe?
I think that this is sort of the root of many of the people that ask, because I don't, some companies are not going to do this, and that's okay. For us, I think part of it is, I'm not answering the question so much as setting it up, but I think that for us, our choice to invest in vendors for many of our solutions, like we build a handful of the things we work on, but we also leverage outside vendors. Like we are not a time series database company. So until we acquire that sort of stuff internally or have a need, we rely on others. So I think the first thing that you can do is leverage existing tooling. As engineers, we so often want to go and build the cool thing ourselves. There's a reason people are still using Nagios. There's a reason people are still using Graphite. Graphite's a great tool. Nagios is a great tool. There's nothing wrong with them. But there's a reason they're still around and have been so popular for so long. Do not try to reinvent the wheel. Just go out and pick the best tools you can find that give you the most bang for the minimum amount of investment. That's like step one. If I had gone out and said, I'm going to build a time series database, I think people probably would have told me to shut up and go back to whatever other thing that I was doing. But then secondly, I think earlier I mentioned finding champions. The finding other people who are also willing to invest is important. If you're not finding other people who can invest, maybe you're barking up the wrong tree. or maybe your pitch is bad. What is it they need? So you asked me earlier about what I learned from asking people. I learned that maybe the thing I thought was valuable wasn't the way they looked at it. Maybe they didn't, need a time series database. They needed some sort of, scheduled check mechanism like what Nagios or Sensu provide. Or maybe they needed tracing more than they needed metrics. So being very receptive and talkative about it is another one. The third way is to involve yourself in places where you can add value. One thing that I do every week is attend our incident review meetings. This was something that when we first started doing them, we didn't have an observability team formally, but I sat myself in that room every Friday and I listened to every incident we had, and I thought, how can I make this maybe not happen again? Because we all know that the nature of these things is that they're going to happen. But how could I have helped to mitigate this? What could my team have done? What could our stack have done that would have made this not a problem or not as much of a problem in the future? And figuring out what metrics around incidents we cared about. Like, were we trying to increase uptime, reduce incidents, decrease the mean time to detection, something like that? Like, where were we in that mix and how could we provide that? Because that's the thing people care about. So find the thing people cared about. For us at the time, it was incidents. But, for you, it may be something else. For you, maybe it's, customers. Maybe you need to know my users are having a good or bad experience and providing that value. Maybe it's the layers that you pointed out earlier. Maybe you need to provide distributed tracing to your teams so that they can get better insight into how all this stuff is flowing. Or maybe it's cost. We talk about observability largely from the perspective of metrics, but maybe what you need to be looking at is spend. Could you be providing value in looking at your AWS bills and sort of tying those back to users? I mean, that's a form of observability just for a different system than the runtime systems we're often speaking about. So, I mean, I hate to beat the drum, but I think it all comes back down to, again, value is the big thing I think we have to be interested in here. What value does the observability thing you want to do provide, and are you doing everything that you can to maximize it?
Cory, thanks for coming on Software Engineering Daily. This has been a great conversation.
I love talking about this stuff, and the questions are really good because I think that no one pops out of this knowing how to solve these problems. I think that's the biggest message back to your question of how to do it. I think being willing to say this is a journey and we're not super good at stuff, I think this is a great platform to be able to do that and to provide some motivation to other folks doing the exact same thing. So thank you for having me.
Software Engineering Daily is partnering with Indeed Prime to bring you tips for the job search and hiring process. If you're looking for a new job, check out Indeed.com/SEDaily and stay tuned to today's tip.
This is Josh Duty, author of Fearless Salary Negotiation, a step-by-step guide to getting paid what you're worth. Here to share 4 key salary negotiation tips you can use to get paid what you're worth. Salary negotiation tip number 1. Do not disclose your current or expected salary when asked for your salary expectations. You will often be asked for this information very early in the interview process, and it can come back to haunt you later on and cost you a lot of money. Instead, tell the recruiter or hiring manager that you're not comfortable sharing this information and you prefer to focus on the value you can bring to the company in this new role. This is a little uncomfortable, but it pays off later on when you get better job offers that have more room to negotiate. Salary negotiation tip number 2. Set your minimum acceptable salary before you get a job offer. Once you get a job offer, things will move pretty fast, so it's easy to make mistakes. One big mistake could be accepting a lower salary than you're comfortable with for a particular job. So take some time to think about your minimum salary requirements for each particular job before you get an offer. Consider things like your market value, how excited you are about the job, how demanding it will be, and how much potential career growth that particular job offers. By setting your minimum acceptable salary before you get a job offer, you'll easily be able to decide whether that job is right for you, and you'll have a nice baseline for negotiating your salary. Salary negotiation tip number 3. Always counteroffer. Most of the time, the offer you received has some wiggle room in case you negotiate, so you could be leaving money on the table if you don't counteroffer. A reasonable counteroffer could earn you a higher salary for very little effort. My rule of thumb is that you should counter somewhere between 10% and 20% above the offer amount. Counter closer to 20% if you sense that the company really needs to fill this role and you're their ideal candidate for the job, and stay closer to 10% if you sense that they aren't very motivated to hire you. And our last salary negotiation tip is tip number 4. Once you counteroffer, make sure to continue negotiating until you've earned the best compensation package possible. Your counteroffer should be focused on base salary, but you can also negotiate other things like vacation time or a signing bonus once your base salary is maximized. My rule of thumb is that if they don't say yes to your previous request, then you still have room to ask for something else. So make sure you identify your 2 or 3 most important non-salary items and be ready to negotiate those once you've maximized your base salary. Use these 4 salary negotiation tips next time you change jobs, and you can earn a lot more money. Go to fearlessSalaryNegotiation.com for more salary negotiation tips, articles, and tools you can use to get paid what you're worth.
Done.